everyone, welcome back to Kidding Around. My name is Melanie Smith, and I think it's terrific that you are here with me on another Test Tube Tuesday. Today we will be talking about glaciers. Before we do that though, if you like what you're seeing here and want to follow along with all of Kidding Around's videos, please make sure to subscribe to our YouTube channel, and also if you really like what you're doing here, please share us with your friends. Okay, so let's move on to the topic of glaciers. Have you heard that word before? Do you know what a glacier is? Well, a glacier is a massive body of ice that moves slowly across land. Glaciers can be hundreds or thousands of feet deep. They form in places where snowfall does not completely melt each year, and over time the weight of the snow piling up compresses the snow beneath it, which turns it to ice. At the very bottom of the glacier, the ice becomes viscous, meaning that it is able to flow and move. So glaciers that form on top of mountains creep downhill, as you might imagine. Most glaciers move quite slowly, advancing only about an inch per day. Though not all glaciers move at the same speed, and the fastest ones can move up to about 150 feet per day. That's half of a football field. I'm sure that you can imagine these heavy, big chunks of ice moving across the land definitely make their mark on the landscape. First of all, they take no prisoners. If there's a tree or a rock or dirt in the way, it just takes it right down. Quite often, that then will be a part of the glacial trail too. It just flows right along with the glacier. Also, glaciers leave their mark on the actual landscape, on the actual terrain. You know, the Great Lakes in the United States were actually formed by glacier paths. There was a divot left in the land by a glacier, and then warm water filled up what we now know as the Great Lakes. So I thought it would be fun today to see if we can make our own glacier, our own yummy glacier. So what you will need for this activity are some Nilla wafers or some wafer type cookies. We are going to use these as the bedrock, the underneath part of the soil that our glacier goes over. And then you will also need some yummy mix-ins. We're going to pretend that these are rocks and dirt and soil that the glacier moves across. So I have some chocolate chips here. They're fun colored, but they are chocolate chips. I have some mini M&Ms, and I have some broken up Oreos. And then you will also need some ice cream. You will need an ice cream scoop. You will need a baking dish, about 13 by 9 probably. And then you will also need a book or something to put your land on. All right, so let's get started. So we are first going to put our bedrock down. So let me move all of this so you can see. We're going to put our bedrock down. This is the stuff that goes under the soil. So I am going to just lay out these Nilla wafers. These are the mini Nilla wafers. And I am going to cover the bottom of my baking dish. All right, so now that I have the bottom of my baking dish covered with the Nilla wafers, I am going to put in my ice cream mix-ins, also known as rocks and soil. That is what these represent. So these are going to represent some rocks, these Oreos. And of course, you can use any type of mix-ins that you want, any type that you like. And then I'm going to use some of these mini M&Ms to represent some of the soil that the glacier might travel over. All right, and then I am going to use some of these chocolate chips as maybe some smaller rocks. Maybe my Oreos are the boulders that get in the way of the glacier. And these are the rocks. Okay, so now I have my landscape all set up. So I am going to raise it up on my binder here. And this is my hill. And now I'm going to put my glacier in. My glacier is my ice cream. So I am going to put it at the top. I want you to make a prediction. Before I do though, what do you think is going to happen? Use what you've just learned about glaciers and see if you can figure out what is going to happen when this glacier goes at the top of this hill. All right, so I'll put that out. I'll put a couple more out too. This is a great family science experiment to do, because then at the end you can split the results of your glacier flow among everyone in your family. All right, let's watch and see what happens. Clearly, this calls for some patience, but don't worry, something will happen. Remember, glaciers don't move very quickly, right? You can see here that some of the ice cream is starting to melt. Obviously, it's starting to melt underneath all of these scoops of ice cream, but I can definitely see it here. And so we just keep waiting. Still waiting. Believe me when I tell you, this actually is sped up. We are just sitting here and waiting. It may take a few minutes. We can definitely see that, but I definitely guarantee that you will enjoy the results once this happens. So keep patiently waiting. Still waiting. Keep the faith. It'll happen, I promise. You can see here that that ice cream continues to melt and it is flowing under the bedrock. But you can also see that it's starting to impact this rock here, and it's starting to touch this dirt. So definitely things are happening. While we're waiting, I'm going to tell you just a few more things about glaciers. Glaciers cover about 10% of the Earth's surface, and they contain much of the world's fresh water. But climate change is causing them to melt. Some glaciers are losing ice really, really quickly, such as the ice sheet that covers Greenland. From 2006 to 2015, that Greenland ice sheet shed about 278 billion tons of ice each year. And that water is contributing to rising sea levels. Some glacier ice is just 100 years old. But the oldest glacier in the world is in Antarctica, and it may be 1 million years old. So we want glaciers in our lives, and hopefully we and you will be able to do something to stop the melting, to stop global warming enough to keep our glaciers glacial. All right, well, let's come back to our ice cream glaciers here. There's definitely some activity going on. I can see that the ice cream is melting. You know, I think at this point I have become a little bit impatient, and I think that I am going to see what happens if I just give the ice cream just a little bit of push. This is Mother Nature. I'm pretending I am a little bit Mother Nature-ish here, and I am seeing if I can affect these glaciers. Well, you know, they are stuck, which is probably good, right, for the Earth overall. So let's wait just a little bit more. I'm so glad that you have packed your patience today. There is activity happening up here. I can see it. It is just a glacial pace. right, I'm going to be Mother Nature again, and I am going to raise this up just a little bit more and see if that has an impact. Of course, you know I'm doing the opposite of what we actually want to do in real life. We want to keep our glaciers from moving as quickly as they are. But for ice cream, well, we can speed it up a little bit, right? You are definitely understanding how glaciers actually work. I am going to be Mother Nature one more time, move it up just a little bit more, and then I am going to give this ice cream another gentle push to see if we can start seeing some ice cream action. You know, the thicker the glacier, the faster it moves. The warmer the glacier, the faster it moves as well. So maybe when you do this at home, you should add more ice cream. That'll give it a little bit more weight. And maybe I was worried that my ice cream, after it sat out for a few minutes during my intro, I was worried that it would be already too warm. But I think maybe if you left your ice cream out just a few minutes before you put it in your tray here, it might move a little bit faster. But of course, this is showing us the speed of a glacier. So it's up to you. All right, I'm going to do it again. I'm going to move it just a little bit more. And then I'm going to give a little Mother Nature force here to see if we can get some glacier movement here. Believe me when I tell you, this is going even slower in real time. All right, we are definitely starting to see some movement. This one I can see is starting to head down. I think we are close now. And while I do still see movement, it's very, very minimal, but I do see movement. I'm going to do one more final Mother Nature force and push down and see if we can get even more movement. And then I think I am going to raise it up just a little bit more. Give it just a little bit of help, because man, I am ready for some ice cream. I've never been so excited for ice cream to melt. You know, I think I'm going to add just a little bit more ice cream to this. See if that makes a difference. Make it just a little bit heavier. As we learned, thicker glaciers move faster, and this ice cream has been out just as long as the ice cream that I put in the pan or in the tray, so it should be good and melty too. Let's see, maybe just a little bit more weight will help with our glacier. Clearly, this is not an actual scientific experiment. I have changed way too many things throughout the course of this experiment. But hopefully it will, at the end, show you exactly how a glacier moves. I have to tell you, I usually do all of our activities ahead of time. I do a test run, and then we do them here together. I didn't do that on this one because I didn't know what our family would do with 2 sets of glacier runoff. So this is an experiment that we are learning about together, and this is also why it's taking much longer than I anticipated. All right, I'm going to be Mother Nature again, that force of Mother Nature, and I am going to try to push the ice cream down just a little bit. We'll see if that changes anything. I mean, definitely we can see that it is starting to melt, and it is starting to impact the soil beneath it. Let's see how much more impact it provides. Have you noticed here at the top that our ice cream, the glacier, is taking the bedrock with it as it flows down the mountain? Obviously, in real life, there would be something underneath the bedrock that the glacier wouldn't take, but it would definitely leave a valley in its path. Every once in a while, you might notice that the Oreos and chocolate chips and M&Ms are moving a bit. Some of that may be because I am holding this tray up and I might actually be jostling it a bit. I'm trying not to, but that might still happen. But I have noticed, because I'm right here, right on top of it, that a lot of that movement happens when the ice cream underneath affects the Oreos or the M&Ms on top. So it is being affected by this runoff of the ice cream. All right, I know I said last time was the last time that I was going to be Mother Nature and impact our glacier, but I'm going to try one more time. We're getting kind of low, and it would be nice if that glacier would make it to the bottom and encompass all of these rocks and bedrock and soil. It doesn't look like it's going to happen in our experiment today, and sometimes you just have to chalk up an experiment like this to experience. So we've got great experience, but we also have some knowledge. We definitely see that the glacier moved the things in its path. It took with it a lot of the cookies, a lot of the bedrock, and we can see down here below, it is impacting the things beneath it as well. Thank goodness that this is a yummy experiment. So I am going to go take care of this by giving some to my family, and then I will come back and we'll do another experiment all about glaciers. It's not as yummy, but I guarantee that we will learn even more. Okay, I am back, and I have to tell you, my family is so very happy with me. All right, well, earlier I mentioned to you that the oldest glaciers in the world are in Antarctica. So Antarctica is the 7th continent, and it is at the southernmost tip of the world. It is a large landmass, and there's ice over most of that land, and there's also ice over the water right around that landmass as well. Those are all glaciers, but I'm sure that you have heard that the glaciers in Antarctica are melting, and that is something we don't want to happen. So we're going to talk a little bit right now about why it happens. So in order to do this, if you want to follow along at home, you will need some modeling clay. You're going to separate it into 2 pieces, and you're going to have a flat piece and then a piece that looks a little bit more like a mountain range runs through it. You will need a shallow baking dish, you will need some warm water, some ice cubes, and then also some toothpicks. All right, so we are going to make our clay into 2 pieces. You're going to make one that's relatively flat and put that on one side of your baking tray. And then you're going to make one that looks like it has a mountain range running through it, like I said. And you're going to put that on the other side of your baking tray. Then you are going to take some ice cubes and put those on Antarctica. So you can put 2 ice cubes on Antarctica. If you need to move your clay around just a little bit so that your ice cubes can sit on top, go ahead and do that. And remember, you want that to be flat. It should be flatter than your mountain range on the other side of your clay. All right, so this is Antarctica, and this is actually a great representation of Antarctica because the ice is on the land, but it also extends out over the water. All right, so now I'm going to pour in some warm water, and this is going to be to represent our ocean. So I am going to pour it just to the top of the land, and I'm going to try not to be touching the ice with the water right now. All right, so there we have our ocean. So I mentioned that this part represents Antarctica. This piece of clay represents inhabited land, so land where people live. All right, so we're looking right now, and we see that the ice cubes are on the land. Everything looks to be pretty normal. And now I want to ask you, because the air around the ice cubes right here is warmer than freezing, What do you think will happen to those ice cubes? If you were able to keep the air around Antarctica below freezing, how would that change what happens to the ice cubes? All right, so right now, our air is above freezing. What kind of impact do you think that that is going to have on these ice cubes? If you said you thought these ice cubes would melt, you are absolutely correct. So our air is warmer than freezing, so these ice cubes are going to melt. And in fact, if you look at them closely, you can see that they are already starting to melt. If we were able to cool the air down around here, and it were colder than this ice, that ice would stay frozen, right? Okay, so now let's add one more thing. We will add some more water now, and we are going to add water to the level of the bottom of the ice cube. All right, so it is touching right there. It is touching the ice, and this is, again, a great example of how it happens in Antarctica. The ice flows out over the water, but the water can touch the ice. Now, if that water is warm, what do you think is going to happen? We're going to let that sit for a little bit, and then we're going to look over here at our inhabited land, and you can see that the water is coming up on the shore, much as we would expect it to, right? Okay, so we are going to mark where the water level is right now on our inhabited island. All right, so I am just putting some toothpicks here to represent where the water level is. Let's see, we'll put it right there as well. So now we are going to wait and see what happens. All right, so now if you look at this, you will see that the ice cubes have melted, but I also want you to look and see what has happened to the water level on this island. When I put those toothpicks in, the water was not right up against them as it is now. You can actually even see that the water is almost around this toothpick. So the melting of the ice in Antarctica has caused the water level to raise over here on our island. Scientists do believe that when an ice chunk falls off in Antarctica or an ice chunk falls off up north in Greenland and it melts, it actually causes rising water levels to the rest of our land. So when the water levels rise other places in the world, it causes a whole host of problems for the animals there. There are animals that need to live in certain depths of water. There are animals that need to live in certain temperatures of water. And if we change that too much, those animals can die. Not to mention the fact that the penguins and the seals who live on the ice and are acclimated to the ice are losing their home as well. So we definitely need to do our part to stop global warming. So that is a big and a huge issue. I will post some links below that you can follow if you're interested in learning how to change global warming. Well, I hope that you have had fun today learning about glaciers. I know that I've had a blast, and I also got a yummy treat out of it. So thanks so much for joining me. I look forward to seeing you on Thursday when we'll be talking about a thoughtful Thursday thing to do. I look forward to changing the world in that way with you as well. We can change global warming, and we can also make the world a happier place to live. I can't wait to do that with you. Thanks so much for joining me for this one. Thanks so much for kidding around with me. I will see you next time.